Our project is mask and no mask face identification using deep learning techniques. Abstract. As we all know that coronavirus disease pandemic is causing a world health crisis, that the effective method for reducing the COVID-19 is wearing the mask in public areas according to the World Health Organization. A COVID-19 pandemic forced all the governments to impose lockdowns to prevent the virus transmissions. Reports indicate that wearing face masks while at work clearly reduces the chance of transmission. Here we used deep learning for mask detection, and a mask detection dataset consists of mask and without mask images. For implementing this project, we used OpenCV to do real-time face detection from the live stream via webcam, and aim of the project is to reduce the time taken to spot and make simple in finding the person is wearing the mask or not within the working environment. It eliminates the unnecessary delays in identification of a person who is wearing mask or not. Scope of the project. The scope of the project is to be integrated with surveillance cameras to impede the COVID-19 transmission by allowing the detection of people who are wearing masks and who are not.
Introduction. In 2020, the rapid increase of COVID-19 has forced the World Health Organization to declare COVID-19 as a world pandemic. It was infected 5 million cases in 6 months over 188 countries, and also people are forced to wear masks in public areas. However, monitoring large group of people is difficult. The process of monitoring involves the detection of anyone who is not wearing masks, and artificial intelligence supported the deep learning. It can help to fight COVID-19 in some ways. It allows researchers to evaluate the quantities of dataset to forecast distribution of COVID-19. Some literature reviews in IEEE journals, and the first one is face recognition using PCA algorithm. In this paper, they are used the effective principal component analysis approaches. In these approaches, it transforms faces into small set of characteristics and eigen faces, which are the main component of initial state of learning images. And the next one is comparative binarization approach for degraded agreement document image from various pharmacies. In this paper, they are inputting the initial set of procedure, and images are captured by the camera by using secondary sources such as scanner. And when the input images is in RGB format, then the images will be transformed into grayscale format. Design and methodology. Dataset collection. In this, we collected some data from the website, which consists of all records of individuals, and it consists of nearly 4,500 datasets. Those datasets will be used as training and testing datasets, and we collected the datasets from the Kaggle.com websites. Pre-processing data. In this, we consist of images with different colors, different sizes, different orientation, different background, and also it includes noises. So we would like to convert all pictures into grayscale because we want to make certain colors must not be juncture from detecting mask. And we possess all the picture within the same size before applying its neural networks, and noise will be removed by using filtering techniques, and back subtraction is administrative by using various techniques to get rid of background. Splitting dataset into training and testing data. The train test split procedure is suitable after you have large datasets. A costly model to coach or require the decent estimation of model performs quickly. So it uses the scikit-learn machine learning to perform the train test split procedures. So it evaluates the machine learning algorithm for classification and regression using train test split.
Implementation. Here we show the implementation in the form of diagrams. First is architecture diagram. Initially, images of with and without mask are collected from the website Kaggle. Input is taken from the user and those images can be sent to pre-processing. After that, image extraction will be done and classification of images is used to detect mask or no mask, and the output will be shown. If the person is wearing mask means it shows green annotation, if not means it shows red annotation. And the next one is data flow diagram, and the next one is ER diagram. This is the process of implementation, and the other is sequence, and the final one is collaboration diagram.
Testing. Here we used 5 types of testings. The first one is unit testing. Unit testing means the planning of test cases that can validate the used programming logic is working properly or not. Here we use a threaded video stream to grab the frame and then we will read, resize and detect the faces if they are wearing mask or not. And the next one is integration testing. Integration testing demonstrated the mixture of components that are correct and consistent. It defines the mask of the image and construct the argument parser by passing the arguments like image, model and confidence. And the next one is functional testing. Functional testing is used to provide systematic demonstrations that functions are available as specified by the business and technical requirements, system documentation and user manuals. White box testing. White box testing is a testing in which the software tester has knowledge of the inner workings, structure and language of the software. And the final one is black box testing. Black box testing is the testing of software without any knowledge of the inner workings, structure or language of the module being tested. This is the input and output design. If we given the input command means the pop-up window will be generated and it shows the output with green or red annotation. If it shows green means the person is wearing the mask. If it shows red means the person didn't wear or properly didn't wear the mask. Conclusion. Conclusion of this project is to reduce the risk of finding a person is wearing mask or not in crowded areas. For this, we install the libraries like TensorFlow, Keras, OpenCV and we use the CNN algorithm to detect the face mask of a person. Here we take the input in the form of images or in the form of video by using webcam. The accuracy of the model is highly desired and can be used as a use case for edge analytics too. Next topic is future enhancement. The future scope of the project is to simplify the checking of each and every person is wearing mask or not in the working environment. For this, we introduce a face mask detector by using webcam to identify the person is wearing mask or not. If not means it will produce a buzzer sound with an alert message, so that it will be helpful to the people who are working in the crowded areas like shopping malls, hospitals, schools, colleges, etc. to recognize the people are wearing mask or not by using this project.
These are the references of mask and no mask face identification using deep learning techniques. Thank you.
Our project is mask and no mask face identification using deep learning techniques. For implementing this project, we use Anaconda prompt. Anaconda prompt is similar to the terminal or command prompt. It refers to a black screen used to type commands by the user. Will set a path for storing file called mask detection system. Here we have two types of data sets. With mask contains many mask images wearing masks, and without mask contains many images having no mask. Under images section, we just have stored some images as input, which consists of pick 1, pick 2, pick 3, and pick 1 consists of with mask, and pick 2 consists of with and without mask, and pick 3 consists of without mask. And here is the code for the model train. Yeah, here we'll just written code for training the model. Here we'll just import all the packages we need and written all the code which is suitable. And here we have written the code for mask detection. This detection occurs through images which we stored as a dataset, that is with mask and without masks. Here we'll just import the packages like TensorFlow, Keras, and NumPy and OpenCV. And here is all the code used for mask detection through images. And this is the live mask detection which occurs through the webcam. And here also we use packages like TensorFlow, Keras, like NumPy, and we'll just use all this code is written for detecting images with the webcam. And here we'll go to encounter prompt, checking whether the path file is correct or not. And the next step is we just listing all the directories in the file. Now we have already discussed all the input images are stored under input images folder. So giving path in the prompt, like a python mask detection .py is the syntax of this, and the image is stored under image. So we just giving the path, and first image is stored as a pick 1, so we have given as pick 1. Yeah, now image is displayed as with mask, showing green annotation. And in the same way we just give as given for input to same python mask detection .py, and also this image is stored under image file. Yeah, pic 2 is stored in the images file. Now we'll get a picture like yeah, see, we'll get here we have both mask and without mask. So we just got a message, alert message like no mask detected. And in the same way we have to check for the third input, and the syntax is the same as 1 and 2. Here for the third input no mask is detected and an alert message is displayed. Now we'll move for the live mask detection. For that syntax is python live mask detection .py. When we use this command, webcam will pop up. Yeah, webcam will pop up, and whether the person in front of the camera is wearing mask or not. And now we'll check with without mask, live mask in live mask detection. For this also the same syntax, python live mask detection dot py. If the person in front of the camera is not wearing mask, will get a alert message and alert sound that you have to wear mask and should stay safe.